This is the first in a series of videos on the sampling distribution of sample means. So let's start with a random variable. Let's say you have a random variable x, and the random variable x has some true mean, true population mean, and let's signify that as mu. And there's also a true or population standard deviation. And let's signify that as sigma, right? The Greek letters signify that they're true values. So now what we're going to do is we're going to take a sample. And if you take a sample, as long as, in specifically, if you take a simple random sample of size n, right? So let n equal to the number of individuals or subjects in your sample, so that's your sample size, then the following things will be true. So let's just think about what we're doing here. We have a random variable x. There's a true population mean and a true population standard deviation. And we're going to take a simple random sample of size n, and we're going to calculate the sample mean. The sample mean, the way we take the sample mean is we simply take all the x's and add them up and divide by n. We can use that if we want to. And we're going to define it as x bar. So that's going to be the sample mean. So let's do an example to think of what we're talking about. Let's say you were at a high school or a college and you wanted to know how tall people were. Well, in fact, at your high school or college, there's a true average height. So mu would be the true average height. The true, or the population, you can think of it that way, average height. But you're not going to know that number. Instead, you're going to take a sample. So let's say, for example, you take 100 people and you calculate their average height. And the way you do that is take those 100 people, measure how tall they are, divide by 100. Now, in that case, what you get is you get what's called a sampling distribution of x bar. And the sampling distribution of x bar is this, is if you take a simple random sample, then the first thing is that mu x bar will equal to mu. That is, the average of your sampling distribution will equal to the true value. In other words, the sample mean is unbiased. Now remember, this is not a single value, this is an estimator. So this is the process, which means if you took one sample, you don't know exactly what you'll get, but on average, if you took lots of different samples, on average you get the right answer. The second fact is that we know what the standard deviation is going to be. And the standard deviation of x bar will equal to the standard deviation of the population divided by the square root of n. And let's make sure we understand the differences here between mu x bar and, sigma x bar and sigma. Sigma is the true or population standard deviation. Where mu x bar is the standard deviation of your estimator x bar. And let's look at a quick example. Again, let's say you have a high school of 1,200 students, And let's say that you knew mu was equal to 68 inches, which, if I did my math right, is 5 foot 8 inches. And then sigma, that is the standard deviation, the true standard deviation, let's say, is 4 inches. Now let's say you take a sample of, let's say, 100. And then what you're going to do is so here's the key. If you take one sample of 100, you get one value of the mean. If you take another sample, in general, you'll get a different answer. And if you take a third sample, you would get a third value. But what we're interested in is if you repeatedly took samples, what is your sampling distribution of x bar? And the first thing is the mean of x bar would equal to 68 inches, because mu x bar is going to be mu. That is, in general, it's unbiased. And the second thing is you won't always get the same answer. There'll be some spread, and that spread is measured by the standard deviation. So that's the standard deviation of x bar. How much variability will you get in your various samples if you took repeated samples? And that's going to equal to 4 inches divided by the square root of 100, right? Because the formula, sigma x bar is equal to sigma over square root of n. So that's 4 inches divided by square root of 10 is 10 inches, so that would be 0.4. And that's how you would calculate in this example the mean of the sampling distribution and the standard deviation of this sampling distribution.